Okay, so first off, hopefully you're listening to this with headphones. Hold your foldable like so. So today we're going to talk about what is scientific notation. So you do miss this lesson in Math 8, but it's a really good real life lesson. So let's go over it. So with your calculator, what I would like everyone to do is type in a really, really big number. I'm just making this up. Times another really big number. And I don't know if you've ever seen this on the calculator. It sometimes will say a decimal and then e to some power. So like, I don't know if you have an older calculator. Instead of e, it says times 10 to some power. So does anyone know why the calculator writes it in that form? So if you don't know, the reason is because imagine multiplying that large number by that large number. So the number is so large, it can't fit on the calculator. So scientific notation is just a way to write very large or very small numbers. Okay, so if you see that on your calculator, that's what it means. So scientific notation, I usually use SN for short. So if you see SN anywhere, that's what it means. And it looks like this. So it's a coefficient times 10 to some power. So your base is always 10. N is obviously your exponent, and it has to be an integer, which means, yes, it can be negative. And A is called our coefficient. And here's the most important part. A has to be a number between 1 and 10. Let's use our compound inequality. A has to be a number between 1 and 10. It can equal 1, it can't equal 10. So it has to look like this in order to be in correct scientific notation. So what you guys are going to do today is you're going to convert numbers into scientific notation, and then you're also going to add, subtract, multiply, divide, and then you're also going to do a real life example. So let's move on. So, to convert this number into scientific notation, I need to put that number in to a smaller number, 1 to 10, right? So A has to be a number between 1 and 10. Now, where is the decimal currently? It's here. Let's move our decimal. 1, 2, 3, 4, 5 times. So since I moved my decimal to the left 5 times, and the reason why I moved it to the left 5 times is now I have a number, 8.72. Is that between 1 and 10? Yes. Multiplied by 10 to the 5th. So since we just finished our exponent unit, I want you to think, what does 10 to the 5th power mean? Right? 10 times 10 times 10, 5 times. So what is that, 100,000? So imagine multiplying 8.72 times a large number, 100,000. What's going to happen is your decimal is going to move to the right 5 times. So if your original is a number greater than 1, you're going to have a positive exponent. This number for part B is going to be less than 1. That means our exponent is going to be negative. Okay, that's just some helpful tips. So again, if I'm asking to write this in scientific notation, it's currently not a number between 1 and 10. This is really what you need to remember. 1 and 10. So let's move our decimal so we can get a number between 1 and 10. So if I move it between 4 and 5, I now have 4.56. Is that a number between 1 and 10? Yes. Now how many times did I move my decimal? 1, 2, 3, 4 times, but it's negative 4. Okay, so if it's a number, originally a number less than 1, it's going to be a negative number. Why is it a negative number? Because if you guys remember your exponent rules, this is really 1 over 10 to the 4th, which means now you're dividing by whatever that is, 1,000 or 10,000. It's moving to the left 4 times. All right, so that's just basic conversion. Now, what if I asked you to convert from scientific notation to standard form? Standard form is just the regular way to write a number. So it's a negative exponent. Negative exponents make small numbers. Move it over, 1, 2, 3 to the left. So now it becomes 0.006. When my exponent is positive, I'm moving to the right. 1, 2, 3, 4. So negative exponent, move left. Positive exponent, you move right. Now, you don't really need to kind of know these rules unless you understand what it means to multiply by 10 to the 4th. So my number is 60,000. This one, so this is a tricky one. It's currently, actually, it's not really in scientific notation because this is not a number between 1 and 10. So here's what I recommend you do. If it's 10 to the second power, right, it's really 10, 10 times 10 is 100. Move your decimal over twice. So 0.6 times 100, like if you guys actually did 0.6 times 100, you're going to get 60. Now let's change that. Oh, actually, it's not asking to write it into scientific notation. It's asking us to write it in standard form, so we're done. Now, if I asked you to change this to correct scientific notation, you would have to first put it into standard form and then change it. All right, let's try and add and subtract. So this is where your exponent rules come in handy. And the reason why I'm going through all of this is because in Math 8, this is a non-calculator lesson. So we shouldn't be using our calculator right now. Add your coefficients. And you keep your base the same because you're adding here. Now, you can only add or subtract if your base and your exponent are the same. So unfortunately for this problem, we can't just subtract our coefficients. Here's another way to do this problem. If you don't like that, you can actually convert to standard form. So 10 squared, I'm going to move over twice. 0.7, move over twice, I get 70. So what is that, 490? Here's my decimal, move it over to make it scientific notation, and I'm going to get the same answer. So that's what you guys have to do here. Let's change these to standard form first, and then convert to scientific notation. If you want to pause the video at any time and try this on your own, feel free to. So 10 cubed, I'm going to move my decimal over 3 times. Same thing as multiplying 6.5 times 1,000. I'm going to move this decimal over twice. So now I'm going to do 6,500 minus 450. And yes, you can do that math on the side. It's not going to kill you. All right, so I get 6050. So now I need to change it to scientific notation. So I need to make it a number between 1 and 10. So I'm going to move my decimal over between the 6 and the 0. 1, 2, 3. And since it's a large number, that's my answer. Okay? All right, moving on. Multiplying or dividing. Let's divide our coefficients. Who remembers the rules when you divide? What do we do to the exponents? Anybody? You subtract. So negative 3 minus 4 is negative 7. Done. It's already in scientific notation. Look at how nice. Divide your coefficients. By the way, I purposely made these so nice for you. Again, here's my rule. Same base. What do I do to my exponents? I subtract them. Is your final answer in scientific notation before you box it? It is. All right, let's try one word problem together. So the bedroom of our house is 1,200 cubic meters. We know that there are 3.4 times 10 to the 9th particles of dust per cubic meter. Write how many particles of dust are present in the bedroom of our house. So here's our question. Which operation are we going to use? If you said to multiply, you are correct. So we're going to take 1,200 and multiply it by 3.4 times 10 to the 9th. So since we do not have a calculator, I'm going to move my decimal over 9 times. One, two, three, 4, 5, 6, 7, 8, 9. By the way, doesn't mean I'm adding 9 zeros. It means I'm moving my decimal 9 spots. Okay, so shortcut. Do 1,200 times 34, and then just add those zeros. Right? You guys can use a calculator for this one. I'm okay with that. Actually, I'm sorry. That's completely wrong, Mrs. Major. Now here's another option, because this is annoying. I agree. You could also convert this. Actually, no, it's not going to help us either. All right, so if you multiply this properly, it should actually come out to 4.08 times 10 to the 12th. Yeah, I'm going to try it on my calculator. You guys try it on your calculator. 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 times 1,200. Yeah, it's just that. Particles of dust. So if the word problems are a little annoying like this one, feel free to use a calculator. I'm fine with that. But just know, best way to solve these is to convert to standard form first and then do the math. So feel free to watch this video again. Please glue this foldable in. You guys are going to just complete a small worksheet practicing the skill. And then just a reminder, this packet is due tomorrow. Yes, you should be able to finish this classwork today. If not, that's also homework. I will see you guys tomorrow.